You might have heard from your secondary school that Newton's first law of motion is the law of inertia. But in the previous video, I mentioned nothing about inertia, right? So, well, it's related to inertia, and here in this video, I will try to explain why Newton's first law is also called the law of inertia. Okay, so what is inertia? Inertia, if you go check it out, its definition, you will know that it's the tendency of an object to resist any change in its state of motion. So you want to resist any change in its state of motion. So it's quite a technical sentence. Let's try to break it down. What does it mean? But we break it down from the back. Okay, so you say we want to resist any change in its state of motion. So what does it mean by state of motion? State of motion is just velocity, right? We know that we describe state of motion using velocity. Right now the state of motion is 5 meters per second to the right. We use velocity to describe the state of motion. So it means the tendency of an object to resist any change in its velocity. But we know that change in its velocity is just acceleration. If you experience any change in velocity, that means you are accelerating. Change in velocity can be speeding up, or it can be slowing down, or it can be changing direction. All these are examples of change of velocity, and if you see change of velocity, definitely you know there's acceleration happening. Okay, so to resist acceleration is a tendency of an object to resist to acceleration. So what do we mean by resist acceleration? Well, if an object has no resistance to acceleration, then it will just accelerate by itself, right? I don't resist any acceleration. I'm very good with I want acceleration. Let's accelerate. So you don't need anything to cause it to accelerate. But if I have some kind of resistance to acceleration, then you have to force me to accelerate. You have to force me to accelerate, and that is where the force come in. Okay, because an object has resistance to acceleration, therefore you need net force to accelerate. Or else if it has no resistance, then it can just accelerate by itself. But that's not what's happening in our world. In our world, all objects tend to resist acceleration. And because we resist an acceleration, we need net force, forcing it to accelerate. That's the idea behind the inertia. So when we have resistance to acceleration, we need net force to accelerate. So therefore, when there is no net force, you see no acceleration. When there's no net force, you see no acceleration. Recall something? Yes, that is your Newton's first law of motion. That's why I always say Newton's first law of motion is slightly related to inertia, or sometimes we even call it the law of inertia, because Newton's first law is actually trying to tell us that if there is no net force, an object won't accelerate by itself. Because all objects resist to acceleration. You need net force to force something to accelerate. Okay? So now let's study deeper on the idea of inertia. The tendency of an object. So means by it's something about an object that will cause resistance to acceleration, and because it has resistance to acceleration, therefore you need net force to accelerate. So something about the object causes the resistance to acceleration. What do you think causes the resistance to acceleration? What about the object causes resistance to acceleration? Let's try to figure it out. So let's say today you have two objects here. You have object A and object B. Object A is 1 kg, object 2 is 2 kg. I hope you are seeing where am I trying to go. So if I want to accelerate both of these objects at an acceleration of 5 meters per second square, then you know that this object A here, if you want it to accelerate at 5 meters per second square, you need 5 Newton of force. Okay, because sum of F is equals to ma. This one is second law, we'll learn it later. We know that the mass of object A is 1 kg. The acceleration that we want is 5 meters per second. So to know that in order to achieve this acceleration, you have to have 5 Newton of forces, 5 Newton of force pushing object A. Only it's able to accelerate 5 meters per second. But for object B, because it's 2 kg, you need 10 newtons in order to accelerate at 5 meters per second square. Because if you use the same formula, sum of F equals to ma, you know that the mass of object B, because the mass of object B is twice the mass of object A, therefore to achieve the same amount of acceleration, you need twice the amount of force. So the mass, the double of mass here, doubled the amount of net force needed to accelerate. So what am I trying to tell here? I'm trying to tell here that if you have a greater mass, you will have you need a greater net force to accelerate the object. Greater mass, greater net force needed to accelerate an object. So do you see that this mass here is actually the thing that is resisting to acceleration? Because the greater your mass, the greater the net force you need to accelerate. Okay, so the mass here is something that is resisting our acceleration right now. And so because we say that something that resists acceleration is the inertia, then therefore we know that inertia is actually the something about the object that we mentioned about. Okay, the mass is the something about object that we mentioned about. The mass is the one that causes the resistance to acceleration. And because the mass causes resistance to acceleration, therefore you need greater net force to accelerate. Okay, that's why we say inertia here is quantified by the mass of an object. Inertia is quantified by the mass of an object because the greater the mass of an object, that will mean you have greater inertia. Greater mass means greater inertia. And because you have greater inertia, we know inertia is resistance to acceleration. Therefore, greater inertia means greater resistance to acceleration. Greater resistance to acceleration means you need greater net force to accelerate. Okay, that's why this inertia here, we say it's quantified by mass. Because you have greater mass, then you have greater resistance to acceleration. So that's the idea of inertia, and here we try to relate inertia using its definition here. We relate it to Newton's first law by saying that it's the resistance of acceleration.